Hi, this is Chapter 10, Section 10.1. We are looking at sampling to proportions. And homework assignment page 630 through 633, number 9, 21, 25, and 28. Number 9. Question is, do younger people use Twitter more often than older people? Of course they do. In a random sample of 316 adult internet users aged 18 to 29, 26% used Twitter. A separate random sample of 532 adult internet users aged 30 to 49, 14% used Twitter. So I'm looking at this and I see number 1, we have two percentages, which could change to proportions. And there's two groups. So that must mean that I am doing a two proportion z-interval or z-test. I don't know, I haven't looked yet. A says calculate the standard error, the sampling distribution of the difference in the sample proportions of blah, 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 blah. Key thing is that they want the standard error. And so you look on your trusty formula packet and you go, standard error, where am I? Oh yeah, we're in inference, so I look on the inference page and I go down here. I see sample proportions, difference in means. Oh, difference of sample proportions. This top one was one we didn't pull. That's your standard error. The bottom one is the crazy one we used for the test, and that's your standard deviation, so you would use for the test. And this top one you use for the confidence interval. Remember, these are given to you. You just need to know how to use them. So, I have to calculate the standard error. Unfortunately, yes, this means you actually have to do some math. Number 9, I want the square root of my first p times 1 minus p over n1 plus p2 times 1 minus p2 over n2, all square rooted. That's all I have to figure out. So, if I plug in, looking at the first one, I'm going to call P1 the 0.26, and P2 was the, what was it? Yeah, 0.14. N1, because I need that too, is we had 316 adult ages 18 to 29, and then in N2 they had 532. So now we just need to plug in the numbers and figure out the math. So we have the square root of 0.26 times 1 minus 0.26 all over 316 plus 0.14 times 1 minus 0.14 all over 532, all square rooted. Get my calculator out. 0.26 times 1 minus 0.26. Oh, can't see that, sorry. Sure, use the calculator appropriately. Divided by 316. Wow, that's really small. Plus 0.14 times 0.86. That's 1 minus 0.14. All divided by 532. That's super small still. Now I have to square root that, which is probably going to make it a little bigger, I think. Second, square root, second, answer. There we go. 0.029 works. So that's part A. And the answer is 0.029. And now on part B, it says, construct and interpret a 90% confidence interval for the difference between the true proportions of adult internet users in these age groups who use Twitter. So they told us we need to do an interval. So I'm going to make a note to myself, 2 proportion z interval, because they just told me to use an interval. I have to do the state plan do conclude. And I'm just going to rewrite the question. We want a 90% confidence interval. For the difference in the sample proportions of younger adults minus older adults who use Twitter. I started reading the end of part A, so that looks a little weird, but it'll work. That's really wordy too. I didn't need to get that wordy. Plan. We have proportions, which is only a bar chart, so we can't talk about roughly symmetric. We have to talk about at least 10 successes and 10 failures. Well, then we had a random sample. So we have random, actually we have 2 random samples of adult age groups. I cleaned the drawer, did you see that? Age groups. If at least, hi Adam, 10 in each group that use Twitter so for the 18 to 29-year-olds, that was 0.26 times 316, which is greater than 10. And for the 30 to 49-year-olds, it was 0.14 times 532, which is also greater than 10. And we have at least 10 that don't use Twitter in each group. It's probably okay if I don't write all that math again. It's obvious that it works. So, okay to use normal model. And I already mentioned above, I'm going to do 2 prop z int. I'm going to jump to my calculator and put in my info. I'm going to hit stat test 2 prop z, oh, not test, interval. There it is. And I have x1, well they didn't give me an x1, but I know that it's 0.26 times 316. Uh-oh, that's a decimal. Calculator's not going to like it. It'll say domain error if you leave it as a decimal. So let's round to 82. And there were 316 there. And then in the second sample we had 0.14 times 532. Of course, again, it's a decimal. Here you could either round up or down. I really don't think it matters much. That's 532. They wanted a 90% confidence interval. Calculate. There we go. Gotta write all that lovely stuff down. So So 0.071 to 0.166. Now I'm going to conclude. I'm not going to be too creative. I'm going to go back when I have to put it in context and rewrite the problem. I'm going to say we are 90% confident that, I'm going to go back to the problem, part B, where it tells me what to do, and it wants me to construct and interpret a 90% confidence interval for the difference between the two proportions of adult blah blah blah. I'm going to write all that down, because that's the context. 90% confident that the difference between true proportion of adult internet users and these age groups that use Twitter falls between 0.071 and 0.166. Thanks, Tony. That was number 9. Moving on, 21. Yay. Driving school. Says the driving school owner believes that instructor A is more effective than instructor B at preparing students to pass the state driver's license exam. An incoming class of 100 students is randomly assigned to 2 groups, each size 50. One group is taught by instructor A, the other is taught by instructor B. At the end of the course, 30 of instructor A's students and 22 instructor B's students pass the state exam. Part A, do these results give convincing evidence at the 0.05 level that instructor A is more effective? So first, reading through this, I see that I have 2 groups, so that's important information. I see that each one is size 50, and in the first group, I have 30 out of 50. That's a proportion. The same thing with the second group, 22 out of 50. Part A, they're asking me for convincing evidence, and they even give me a significance level. If they want evidence, that means we need to do a test. So, with all that said, for 21A, we need to do a 2-proportion z-test. That's what we're going to do in the calculator. So, I have to state, I'm just going to write them as PA, proportion A, and proportion B for the 2 different teachers. So my HO says that everybody's always equal. So proportion A equals proportion B. My HA, the owner thinks that the Professor A is better than Professor B. He's more effective, so he has more students passing. Plan. Oops, I wrote plan. That's all you have to write for your condition, for your state part. That's enough of a description of your parameter. Don't go further with that. Plan. Do we have random samples? Yes. Yes, 100 students is randomly assigned, so don't say they're randomly selected. Say 100 students were randomly assigned. That's important. Second part is we need at least 10 successes and 10 failures in each group. So we have at least 10 students that pass the driver's test and 10 students that don't pass in each group. I'm going to show that math by rewriting. Oops, sorry about that. By rewriting, I've got in parentheses for Professor A, or Instructor A, yeah, Instructor A had how many pass? 30 pass and 20 don't. And then Instructor B had 22 pass. And what would that be? 50 minus 22 is 28 don't. So those are conditions, they're met. So okay to apply normal model and to proportion z-test. You okay, Tony? Tony, you okay? Alright. There you go, calculator to prop z-test. Stat test to proportion. Oh, number 6. And they actually gave me whole numbers this time. That's nice. 30, 50, 22, 50. I wanted Professor A to be better. I put A in first, so if I'm confused which way to go, I'm going to copy that symbol that's in my HA. It's pointing to the right, so this one should be pointing to the right as well. That one. Calculate. There's my stuff. Now I just got to write it all down. And notice that if you arrow down, there's a p-hat 1, p-hat 2, and that other p-hat is your p-hat pulled or combined. Just write it all down. So I've got z equals 1.601. My p-value is 0.055. And then p-hat for the group A is 0.6. P-hat for group B is 0.44. And then p-hat pooled is 0.52. And then the conclude is your p-value low. This is our main p-value we're looking at. 0.055. I would say that it's more than 0.05 because you could round that up to 0.06. So with a p-value that is not lower than alpha equal to 0.05, we do not reject HO. We do not have evidence that, and look back at your instructor, or rewrite the question. Instructor A, where's Instructor A? Said that Instructor A is more effective. that instructor A is more effective than instructor B. That was part A. That was long. B. Describe a type 1 and a type 2 error in this setting. Which error would you have made in part A? Let me go backwards because part B, which error will we fail to reject our HO? So we would / could have made a type 2 error since we failed to reject HO. Type 1 error we say we decide that instructor A is more effective than instructor B. When the truth is he is not. Consequence: instructor B could have gotten fired. Could have been fired for being ineffective. And then type 2 error. Type 2 error. We decide that instructor A is not more effective and instructor B but the truth is that instructor A is more effective. Consequence: the owner keeps paying instructor B even though he's doing a bad job. Okay, now we just have some multiple choice questions to do. Number 25. (25 through 28) by Arthur. we have to refer to these ones. It says the exercises 25 to 27 refer to the following setting. A sample survey interviews simple random samples of 500 female college students and 550 male college students. Researchers want to determine whether there's a difference in the proportion of male and female college students who worked for pay last summer. In all, 410 of the females and 484 of the males say they worked for pay last summer. Take PM and PF to be the proportions of all college males and females who worked last summer. The hypotheses to be tested are, well, we have two different groups, and researchers want to determine if there is a difference in the proportion. So since we have the two groups, the whole, remember, is always equal to, and meaning the two groups are equal. If you look at your options, they did that whole subtraction thing. So basically they have to equal 0. So that means I'm going to rule out D and E. Cover those up, scratch them out. Well, it's your book, so don't scratch them out in the book. And then we have to go back to the researchers. We're trying to determine if there's a difference. Well, that means the not equal to, not the other ones. So 25 should be A. 25 A. 26. The researchers report that the results were statistically significant at the 1% level. Okay, if they're statistically significant at 1%, that means their p-value is smaller than 1%. Which of the following is the most appropriate conclusions? Because the p-value is less than 1%, you fail to reject the HO? No, that is so wrong. So don't even read the rest of that one. It's wrong. Scratch it out. B, because the p-value is less than 1%, fail to reject HO? Again, nope, not correct. C, because the p-value is less than 1%, you reject HO. Okay. There is convincing evidence that the proportion of all male college students who worked for pay last summer is the same as, no. We're supposed to say there's convincing evidence that there's a difference. There's evidence for the ha. So it's not C. Because the p-value is less than 1%, you reject HO. There's convincing evidence that the proportion of all male college students in the study who worked for pay last summer is different from the proportion of all female college students in the study who worked for pay last summer. Hey, that one sounds pretty good. Let me look at E, though, just in case. Because the p-value is less than 1%, reject HO. There's convincing evidence that the proportion of all male college students who worked for pay last summer is different from the proportion of all female college students who worked for pay last summer. How are those different? There's convincing evidence that the proportion of all male college students. Ooh. This one's saying who worked for pay last summer, and this one's saying in the study. Big difference. Now we gotta think about the population. This is talking about the proportion of all male college students who worked for pay last summer, and this one's just in the study. So, sample survey interviews, gonna relook at the question of 500 female college students, 550 researchers want to determine whether there's a difference in the proportion of male and female college students who worked for pay last summer. So we don't want just the study, because if we talk about just the study, then that's just the sample. Somebody asked me a question about that today, and I didn't even look at the problem, and I'm pretty sure I told them the wrong information. It should be for the whole population when you write the conclusion. So it should be E, not for the study, but for everyone who worked last summer. So 26 should be E. So I apologize to whoever it was that I told the wrong answer to. 27. Oh yay, these ones are fun because you just gotta look at the formula. So as soon as you see one like this, grab your formula packet so you have that handy when you're comparing notes. It says, which of the following is the correct margin of error? Margin of error is, if you look up here, confidence interval, this whole part right here, your critical value times standard deviation of your statistic, that's your margin of error. This standard deviation of statistic is your standard error. What's the SE? So, I'm going to go down and look at this one. 99% confidence interval. Well, I got to look up my Z-star, because I noticed right away that they're not all the same. I know it's 2.576, but we'll review. Look it up on your table, not this one. Go to that T table. You go down to where it says infinity, and go over to 99 and go up, because those are your Z-stars, 2.576. So that means D and E are wrong. Now I'm looking at the actual values they gave me. This one is a pooled. We don't want pooled here. That would be for a test. We're doing a confidence interval, so it's not B. And then this one up here also used the pooled information. Actually, that one pulled it incorrectly. This one also used the pooled stuff. So it should be C, 0.88 and 0.82. So C, 27 should be C. And then 28. In an experiment to learn whether substance M can help restore memory, the brains of 20 rats were treated to damage their memories. Lovely. First, the rats were trained to run a maze. After a day, 10 rats determined at random were given M, and 7 of them succeeded in the maze. Only 2 of the 10 control rats were successful. So they gave them, oh, restore the memory. Okay, so they should have done it better. All right, the 2-sample Z-test, oh yeah, they're trying to throw you off, aren't they? For no difference against a significantly higher proportion. I know they said 2-sample Z-test, but they're talking about proportions. So this is the same thing as a 2-prop Z-test. And a significantly higher proportion of M group succeeds gives. So we want group M to succeed. This means we have to plug it into our calculator. Uh-oh, look at D. It says should not be used because the random condition is violated. Were they randomly chosen or randomly assigned? In an experiment to learn whether substance M, the brains of 20 rats were treated to damage their memories. After day 10, 10 rats determined at random. Oh, so random's okay. This one says, what's E say? Should not be used because of the large counts condition is violated. Are we going to have at least 10 successes and 10 failures? Do we have at least 10 successes and 10 failures? No, I don't think we do. So I think that this one should be E, because you only had 2 out of the 10. We're trying to see if they're the same. I don't think you have enough. Let me double check that really quick. The 28's probably E. Watch me be wrong. I'll be broadcasted on the internet. Lovely. 28, where are the answers? 10 point something. What? Oh, it's not in the answer. That's what Callie was trying to tell me. Hold on, I got a master book. .28.
Are you all up a master book?
No, you're not allowed a master. Yay! I was right. It should be E. 26 was also E. Did we write 26 was
Yeah,
E?
we did.
We did? Okay, good. Yes. So that's the first assignment. I'm going to shut it off now and then I'll record another section.